So Generation 3 blockchain technologies are blockchain technologies that aim at solving some of the problems of the first and second generation blockchain technologies. Of course, Generation 3 blockchain, Generation 1 blockchain has come, I mean, the Bitcoin, it has come, it has opened our eyes, it has shown us that, look, we can have endless, we can have a lot of possibilities, we can have money that is not controlled by a central authority. Generation 1. Then Ethereum Generation 2 came and showed us, look, the blockchain can be beyond just money. The blockchain can be crazy. The blockchain can be used for a lot of things. Just imagine it being used in the hospital, being used by lawyers in their legal system, being used for land purchases, being used by musicians, being used by artists, being used by cooks, being used by, think of everything, hotel management team, softwares that will be running on the blockchain, your Uber and every other thing will be running on the blockchain. So the blockchain, the Ethereum guys and the second generation guys told us that, look, we can extend whatever the blockchain is doing beyond just money. It can transverse, it can be used across different fields. In fact, across every single field of life, even agriculture, even electrical energy. I'm an electrical electronics engineer. Okay, I studied electrical electronics engineer, and the blockchain is going to be doing so much when it comes to trading of energy and a lot of that. So we'll look at that shortly anyway. So the Generation 2 blockchain guys have opened our eyes to the endless possibilities we can have with the blockchain. Generation 3 blockchain guys are now saying, look, Generation 1 blockchain and Generation 2 blockchain have opened our eyes to the endless use case possibilities. Now, but they have some setback. Of course, once something starts, at first, the program is going to focus on trying to solve the problem. Okay? So, but after trying to solve the problem, the next thing will now be, the way we have solved this problem, let's optimize it. Let's make it scalable. Let's make it interoperable. Okay, let's handle a lot of other challenges we were having. So this is basically what Generation 3 guys are trying to do. They're trying to, of course, solve more problems, but majorly fix some of the challenges that Generation 1 and Generation 2 blockchains have. So examples of Generation 3 blockchains, of course, Ethereum 2.0. I love Ethereum so much. I love Ethereum so much because without Ethereum, I don't think I will be standing here today. I don't think I will really have the confidence to think of doing things on the blockchain, because Ethereum provides us with a programming language with which we can write codes that have write codes to build software applications that have the features of the blockchain. You, for instance, if without Ethereum, trying to set up your own blockchain, I mean, it's crazy, super expensive. It's going to take perhaps a long time to even get to the market, to even gain adoption and the rest. But Ethereum, the Ethereum guys built a platform, and it's more like a programming language. It's also a platform, it's also an internet, it's a lot of things. So, but they built a platform where people who want to build things that have these characteristics of the blockchain, of course, which are the fact that it is decentralized, it is immutable, it is transparent. Okay, decentralized, it is no single person is in charge. Immutable, anything there cannot be changed. Transparent, anybody that's on the blockchain can see what is happening on the blockchain. So these three properties, when you want to build softwares that have those features, usually if you want to start on your own, it's going to be crazy. Where are you going to get the nodes? Where are you going to get the whole setup? But Ethereum has provided a platform where you can just write with some codes, access their own engines, access their own nodes, and be able to get those functionalities of the blockchain. So Ethereum is crazy. Without Ethereum, I don't think I'll be standing. I don't think I'll really pick so much interest in the blockchain. So I love Ethereum so much. And now Ethereum has, of course, the Generation 2 blockchain. It is the Generation 2 blockchain itself, kind of. But now they are trying to also solve some of their own problems by bringing out Ethereum 2.0. That's going to solve a lot of all those problems we mentioned earlier. So it's crazy. Then another Generation 3 blockchain is Cardano. Of course, Cardano. Then another one is Polkadot. Cardano and Polkadot, funny enough, the founders were co-founders of Ethereum. They were all in Ethereum. Then they had to move. The founder of Cardano founded Cardano. Then Gavi founded Polkadot. Okay. Then another crazy one I have here is Solana. Oh my goodness. Solana is another very crazy blockchain project. When you go to Solana's website, what intrigues me a lot is they purposely put it there that, I mean, bring in your codes, bring in your algorithm, try to stress our network and see. They are very confident of what they have. So Solana is another very crazy blockchain that is doing a lot of amazing things. And And the beautiful thing about Solana is why a lot of other projects like Ethereum 2, Cardano, and Polkadot are still proposing a lot of things. Solana has achieved some of those things already. Anyway, it's going to be beautiful, and we're going to really look at all these things. So, now remember we said Generation 3 blockchain technologies are trying to fix some of the challenges that Generation 1 blockchain tech and Generation 2 blockchain tech have. So, the different Generation 3 blockchain projects have different ways they try to approach it. I would not want to look at all the Generation 3 blockchain projects because there are so many. So, but what I would like to do is just to pick one of them and see how this one project tries to address some of those problems I stated earlier. And so, before I proceed, I would like you to guess which project do you think I will be picking as a case study? Can you guess? Alright, I'm sure you got it wrong. I will not be picking Ethereum. I mean, I know you were thinking this guy likes Ethereum, so you'll pick Ethereum 2.0. I wish I'd be picking Cardano. Cardano. I can pick Ethereum 2.0. I mean, I can pick Solana. I can pick anybody, but I want to use Cardano. Okay, and basically you'll find out why I'll be using Cardano, because Cardano, almost every single thing Cardano tries to do is reviewed. I mean, it's reviewed peer-to-peer by very, very highly proficient people who are very proficient in the space. So Cardano wants to do something, they don't just go ahead and start doing it. They don't just go ahead to start solving a problem. They document it, then they provide it to a lot of people who are very good in the space to review and review and review and review until they can come up with something. So why I'm picking Cardano is, of course, this is for an academic purpose, and we are basically, at some point you might want to go and research more on one of the things I am saying. So Cardano has a lot of paperwork for a lot of things. Okay, so I'm picking Cardano, but aside that, I'm still just picking Cardano because I love the Cardano project also. Anyways, we will see a lot, but most of the time during the course when we start programming, we will most likely use more of Ethereum, and perhaps we'll try some things with Binance Smart Chain. Okay, so Cardano was founded by Charles Hoskinson. I don't know if I'm getting the name right, but I think Hoskinson or Hoskinson, well, I call him Charles, and I love him a lot. I follow him on YouTube. I see a lot of amazing things he's doing. I mean, he's a very smart guy. So Charles was one of the co-founders of Ethereum. He was there in the early days, and they were working on Ethereum. And after some time, from one or two things, he went over and founded Cardano. So let's see, how does Cardano hope to solve some of the Generation 1 and Generation 2 problems. So we'll be taking Cardano as a case study, and we'll see how we're trying to do this. Alright, the first, of course, remember, when we're talking of Generation 1, oh, thank God I've not touched that part. The first big challenge we said we had was scalability. Okay, scalability was the first big challenge we said Generation 1 and Generation 2 blockchain has. And we said scalability itself, I touched that part, has three core challenges under it. Okay, can be broken down into three. The scalability problem can be broken down into three, which is what? Transactions per second, network bandwidth, and storage. And then storage. These are the three core problems under scalability. Okay, so let's see. Now, transaction per second, of course, we already know. I told us the last time, Bitcoin can manage to do 4.6 transactions in a second. Ethereum can manage to do 20 transactions in a second. But, of course, let me just pick Ethereum, for example. Ethereum is claiming to be that internet of blockchain, that's the new internet, okay? Remember, in case you don't know, most of the things we do on internet now, we call it Web 2. Okay, but when the blockchain fully matures, we'll be calling it Web 3. In fact, Web 3 is already there. Web 3.0 is there. And it's basically blockchain and blockchain applications. Okay, so Ethereum is saying I am the internet of Web 3. I don't want to make it confusing to you guys, because this is the way I'm picturing it in my head. So but Ethereum is saying I am the internet, like the internet for Web 3. Okay, a lot of apps will be there. The old operating system for Web 3, kind of. That's what Ethereum is saying. So just imagine a lot of people are not building. Just imagine your Jumia app for those in Nigeria, your Amazon app for those in the US and all that, your AliExpress, think of all these apps, your Twitter app, your Facebook app, your WhatsApp app. Think of them running on the Ethereum blockchain. That means a lot of crazy things will be happening. Of course, when we say transactions, your transaction might not really be might not have to do it might not have to do with money per se, but just have to do with some other crazy things happening, like a chat, you chatting with somebody and all that. So all these transactions are there. Okay, in short, currently there is an app called Status. It's like a chatting app that is built on Ethereum, on the Ethereum blockchain. And of course, it has the features of the blockchain. It has a lot of advantage over WhatsApp and the rest. But of course, it's still young because blockchain still has a lot of issues. So there are still some things they need to work on. So, but imagine Ethereum becomes this crazy model of the internet. But it can just take 20 transactions per second. I mean, this will discourage a lot of business. It will be so slow, things will pile up. You might try to send message and it might take, at some point, it might begin to take weeks for one of your message to get delivered because things are already on queue. A lot of things are piling up. So Ethereum has to scale, isn't it? And why a lot of businesses might not even adopt it yet is businesses, currently MasterCard is doing about 5,000 transactions per second. Ethereum is just doing 20. So let's see, Cardano has to solve this scalability problem, or any generation 3 blockchain needs to solve this problem. Because generation 3 is now focusing on let's now just leave solving some problems to expanding to adopt more people. Ethereum has been able to use blockchain to solve core problems, but let it now scale to adopt more people so that a lot of people can use it, not just a few people. So Cardano is one of those projects, like, let's see what we can do to work on this. So Anna, how does Cardano try to attack this? First of all, let's start with the transaction per second. Cardano hopes to solve the transaction per second problem using the Cardano Ouroboros. I have it here, Ouroboros. I don't know if I'm pronouncing it rightly. If you're a Cardano professional here, I mean a Cardano genius, Cardano, you work in Cardano, you're a developer for Cardano. Pardon me if I'm pronouncing it wrongly. But this is Cardano Ouroboros. I love Cardano so much. So Cardano Ouroboros, basically, according to the Cardano's website, of course, from Cardano's developers, Ouroboros is the first provably secure proof of stake protocol and the first blockchain protocol to be based on a peer-reviewed research. Cardano is the first provably secure proof of stake protocol and the first blockchain protocol to be based on a peer-reviewed research. From what I've said, there's a keyword that should be striking us. There are some keywords that should be striking us. Okay, so but the first is we are seeing the word proof of stake. Proof of stake. If I may ask you, what this proof of stake, what does it sound like? Have you had anything similar to this before in the course of this course? In the course of this course, you know, sometimes when we say you are taking a course, have you ever really thought of it? I've spent times to imagine it. When you say someone is taking a course, of course, because all of us are becoming too academic, we just have this idea, course is a subject and the rest. But try to look at the word course. Course is like a path. You are taking a path. So I really want to appreciate you once again for taking this blockchain course, this blockchain path, and I pray you are not going to regret it. I'm very, very sure you're not going to regret it because this technology is coming to revolutionize the world, and I'm one of the strong believers. So during this course so far, in this course, have you heard of anything that is similar to this? I'd like you to think for a minute. All right, I know you're very smart. You actually got it. Proof of work. There's something called proof of work that sounds more like that. This proof of stake sounds like proof of work, isn't it? So what do you think? What do you remember from proof of work? When I was talking about proof of work, what do you remember? Do you remember something about proof of work? Of course, yes. Proof of work is alright, very good. You got it again. Proof of work is the consensus algorithm for the Bitcoin blockchain. I remember what was happening during proof of work. In proof of work, all computers have to compete to solve a mathematical problem. The computer that gets it will be the one to create the next block, isn't it? So, but the problem is because the mathematical problem is so hard, it might take even the superpower computer about 10 minutes. That is what the Bitcoin developers designed the Bitcoin blockchain to do. That even if you bring in a very supercomputer, Bitcoin network has to increase the difficulty of the question so that even that very supercomputer will take 10 minutes to solve that problem. They have their reasons for this, and by the time we start looking at deep into some part of Bitcoin later during the course, we will see why. Okay, so they have a lot of reasons why they have to put this. In short, there's a lot of argument on whether they should work on reducing this because I hope I'm not talking too far, but let me just digress a little. And remember, we said the Bitcoin can only take 4.6 transactions per second. So the Bitcoin company, let me use that word, Bitcoin company, Bitcoin developers, they are working on, because if the Bitcoin is to gain massive adoption, businesses start using it, different people start using it, corporations start adopting it, they have to, this transaction per second cannot work. So they are working on looking at a way of making Bitcoin to be able to take more transactions per second. But one of it will be to tamper with that difficulty level, which Nakamoto Satoshi or those who invented the Bitcoin had wanted to ensure that on an average it takes 10 minutes for any new block to be created. So the new developers, for Bitcoin to gain massive adoption and for them to increase the number of transactions per second, they want to reduce that time frame to make the difficulty at least maybe in a minute a block can be created. If they can do that, they'll be able to increase transactions per second. But there are a lot of challenges that will also come up once they do that. But we'll look at that later. So I'm just trying to raise up something. I just digressed a little. I pray you understand what I just said. Okay, because I was just trying to explain the challenge, what the advantage that I was just trying to explain that the whole proof of work thing, with each computer taking 10 minutes to be able to solve the question, the fastest computer will at least, on an average, sometimes it can be a little below, sometimes it can be a little more, but on average, take 10 minutes. That thing has an advantage. So Bitcoin developers want to make Bitcoin process more transactions per second, because that 10 minutes thing is what is causing Bitcoin to be able to do only 4.6 transactions per second. So the developers want to scale Bitcoin to be able to do more than this, but they need to tamper with that difficulty issue so that the fastest computer can at least do a block in less than 10 minutes. But once they tamper with it, it will have a lot of challenge that will come up also, which I don't want to dive into. So basically, I just tried to show you now that this proof of work is like one of the core reasons why the Bitcoin blockchain is taking long. Can only do few transactions per second because it takes a long time to create a block, isn't it? It takes at least on an average 10 minutes to create a block. So, so one of the ways Cardano plans to tackle this transaction per second problem is not to even use this proof of work algorithm where a lot of computers will be solving the problem, but to use something called proof of stake algorithm. So proof of stake is another consensus algorithm. There is proof of importance. There are a lot of other ones. You can really check them. You can just go and Google. In short, there's an assignment for you. An assignment for registered students of the Pan Atlantic University. Send it to me on via mail. Okay, respond to me via mail, or you can chat me up on the school's e-learning platform. Okay, send me. I'm going to record this assignment. Okay, tell me 3 other consensus algorithm apart from proof of work and proof of stake. Of course, during the course of this course, we might meet other ones anyway. So, but for now, as an assignment, apart from proof of work, proof of stake, tell me 3 other consensus algorithms that you can find. Just go on Google, it's there. Okay, so send it to me either as a mail or use the Pan Atlantic University's e-learning platform to reply me for registered students. For those watching on YouTube, you can just drop it as a comment below. I'm going to check it and we discuss it. Thank you. So Cardano plans to use proof of stake instead of proof of work. Why? Because of course we've seen the proof of work problem. So the question is, what is proof of stake? What is proof of stake? I have a note here. Let me start by reading it. Proof of stake, also called POS. Proof of stake. POS. Usually the proof of work is also called POW. Okay, so proof of stake, also called POS, is a consensus mechanism or algorithm whereby the node choosing to create a new block is elected based on the amount of tokens staked. So what this is trying to say is, remember, the idea of the whole proof of work thing, nodes competing to solve a mathematical problem, is to decipher or to know which node would be eligible to create the new block. Is to elect the node that will create the new block. And of course, they have to compete by solving the problem that is so difficult. Okay, that problem can take humans years to solve. So now, the crazy thing now is this: in proof of stake, since the idea is just to elect who will create the new block, proof of stake now, instead of trying to give every computer on the node a mathematical problem, rather they elect one of the computers to just create a new block. Instead of every computer trying to solve a lot of problems, the computers are elected. Okay, and now all the consensus algorithm has different way they elect the computers. Of course, I just explained that proof of work elect it by they competing to solve a problem. Whoever solves it is elected to add a new block. Proof of stake, the way of electing the computer that has a new block is based on the amount of a token staked. The Cardano platform has Cardano tokens. We'll be coming to cryptocurrencies very soon. So the Cardano platform has Cardano cryptocurrency, which those nodes on the Cardano network that are trying to verify block, we have to stake. Okay, so they have to stake. Stake means they have to bring. Let me just put that way, but it's more than that. But let's say they have to bring these tokens. So the proof of stake now, based on the amount of the tokens you bring, you'll be elected to verify a block. Now, I know some of you will say, come on, this is crazy. This platform is favoring the rich and those that have a lot of tokens. But it's not just that simple. There are a lot of other things we will see. So, but what I just want you to get now is proof of stake is that the networks that will add the next block to the blockchain, of course, you understand this now. I've explained how the blockchain works. So the network in the previous video, if you've not watched that, you can go back and watch it. So, but the network that will add the next transaction block, that will record the next transaction, unlike proof of work where the computers are competing, the network will be elected based on the amount of money staked. So all the nodes will stake some amount of money, amount of Cardano on the Cardano blockchain. They will stake it. So the node that has the highest amount will be selected to add the new block. Of course, if you don't understand this adding of a new block thing, you can go back to my video on how the blockchain works. You really see, you get it clearly. Then you can come back to continue. So Cardano uses proof of stake. So this Ouroboros mechanism is a type of proof of stake. Okay, so of course you know what proof of stake is now. The computer that verifies the block, or the computer stakes some money, the computer with the highest amount of money, highest amount of token, will be allowed to add the next block. Now, in the Ouroboros chain, in Ouroboros, which is the method Cardano is trying to use to solve this transaction per seconds problem, the chains are divided into epochs. Okay, now this is getting more interesting. Let me wipe this part off. I wouldn't have loved to wipe this off, but let me just wipe it off. Or is there another thing I can wipe off here? Okay, let's see if we can manage this side, because we are still on the scalability issue. So what happened is in Ouroboros, the blockchain is divided into epochs. So, but let's take a time frame. Let's say from 5 a.m. to, let's say, 10 a.m. Okay, let's pick this time frame. So what happens is this: Ouroboros divides this into epochs. Epoch. Let's say this is an epoch, this is an epoch, this is an epoch. Of course, you know what an epoch is now. Basically, you can Google it. Epoch or epoch. I don't know. Pardon me and my grammar. So epoch, more like this. So more like a time frame, basically. So this time frame is divided into time frames or epochs. Okay, and let's continue from here. And these epochs, basically, they are also divided into slots. I'm opening my side. All right. So we said in Ouroboros, chains are divided into epochs, which are further divided into time slots. So we have epochs, and these epochs are now divided again into time slots. Slots. In this epoch, then slot. In this epoch, then slot, like that. Then each of these slots is appointed a slot leader, okay, based on the amount that is staked, because we are using proof of stake. Alright, so most likely, of course, I don't know too in depth on how Ouroboros works. Of course, I've not been working too much with Cardano. So, but I want to believe, based on the amount staked, okay, let's take what I believe most likely. Based on the amount staked, let's say perhaps someone staked 200,000 Cardano. Let's say that is the highest staked person. That person can be the slot leader for this in this first time. Then the person with the highest next highest stake takes this second slot like that, like that, like that. So at least it's more distributed. Of course, doesn't mean it to get to the person with the least stake, least staked amount, but at least it's more distributed, most likely perhaps. So, but the idea is the time frame. Let's take a time frame. The time frame divided into epochs, and each of the epochs is divided into slots, and each of these slots has a slot leader. So we already know in this slot time frame or in time, there is someone that is supposed to add the block. So the leader has already been elected. So we are not trying to compete to know who is going to add the block. We already know who is going to add the block because the Ouroboros algorithm has already created epochs, and epochs divided epochs into slots, and each slot has a leader. So whoever is slot leader then is going to be the one to add blocks. So other computers then would not start solving problems or do the other thing. They will all just be there, be chill for whoever that guy is. So because the decision has been made already, it's going to be very, very fast. The guy that's supposed to do the transaction just go ahead and does the transaction. Okay, so we are not trying to elect. We already know who is going to do. We already know this time frame, this time slot in this epoch. This guy is a slot leader and is going to be the one to validate and create a new block. Alright, so let's see what I have here in this slide. Of course, Ouroboros makes Cardano flexible because it can run multiple slots in an epoch. Of course, I just showed you. This is an epoch, and each epoch you can have a lot of slots in just one epoch. And the beautiful thing is it can even run multiple epochs at the same time. So in this same time frame, we can have another epoch, another epochs, another set of epoch, another set of epoch, and this set of epoch have their own time slots, and people are elected to do so. As they say have a slot leader at this time, there is another slot leader again at another kind of slot. So I don't know, I don't want it to be too complex, but on a very basic level, the idea is the time frame divided into epochs, epochs divided into slots, and each slot has a slot leader. So on the blockchain, the computers are not competing to know who will add the block. They already know this is slot leader for this slot, so that guy just go ahead and adds the block. So more like it is a little more complex than this. Like I said, also I'm not too in depth on the Cardano Ouroboros yet. Okay, so but I believe this is something, at least from what I know of it, because I love reading. I love reading about the project Cardano, and I'm still researching on Cardano. So far, this is basically how Ouroboros works. Alright, let's see more things I have here. Currently, Cardano only does 257 transactions. Of course, Ouroboros is also still in progress. It's not as if it has gotten to this state. These things I just explained now seem so easy to explain, but in coding, in actualizing, it's not as simple as this. Running multiple epochs at the same time. It's not as simple as you think it is. So, but currently, Cardano is still in progress. They can handle about 257 transactions per second. But we see that Cardano says very soon they'll be able to add a secondary layer to Ouroboros. When I mean the layer, like a layer of code, more layers, okay, to Ouroboros. They're able to add some more features to Ouroboros. Just look at it that way. This to the Ouroboros base layer, and this second layer will be called the Ouroboros Hydra. My board is scattered. Let's touch it up a little. So the second layer that it will have is going to be called Ouroboros Hydra. Alright, Ouroboros Hydra. And we said with Ouroboros Hydra, it's going to be possible for Cardano to process millions of transactions per second. Of course, I believe with Ouroboros Hydra, that's when we'll be able to have this running of multiple epochs at the same time. So it will enable Cardano to be able to take millions of transactions per second. And of course, once Cardano can break up to millions of transactions per second, it's going to be crazy. It's going to be beating MasterCard and Visa card and most of the conventional business or financial management softwares we have so far, or companies we have so far. So Cardano with Ouroboros Hydra can take up to a million transactions per second, and that's going to be super amazing. And of course, with that, come on, we have solved, because imagine a lot of us use MasterCard now, and MasterCard is basically doing just 5,000 transactions per second, and it feels like it's seamless. Of course, it's not really seamless, but it feels like it's seamless. Imagine Cardano being able to do a million transactions per second. It's going to be crazy, and it's going to be beautiful. So this is how Cardano plans to tackle this transaction per second problem. It's not too in-depth what I've said, but at least it gives us a basic overview. Okay. Now, let's see the other problem with scalability is network bandwidth. Alright, network bandwidth. Sorry, I'm going over to the next slide. Network bandwidth. Now, for network bandwidth, Cardano basically plans to solve this problem using RINA, using something called RINA. Of course, the first thing you need to realize is the name is just a name for the whole thing, so don't get confused about the name. Don't say these terms are too much. The name is just a name for whatever they are doing. So the idea is to understand what RINA is trying to do. Just like we said, Ouroboros. It sounds for me, it sounds nice. I love the name. Come on, but for some people it might sound too crazy. But the idea of Ouroboros is just to divide the whole time frame into epochs, epoch into slots, and we know that in this slot there's a leader here. There's a leader for this slot, there's a leader for, so this second there's a leader, this other second there's a leader, and this leader is the one that will add the block. We don't need to start competing. That's basically what Ouroboros is doing. Then with Hydra, they can run multiple epochs in the same time, and the rest. So like that. But for this other one, to handle the network boundary problem, do you remember the network boundary problem? Do you remember? Take a minute. If you can't remember, just go back to the slide and read about it. Take a minute. I'll pause, not for a minute anyway. Let's say for like 10 seconds. My water has finished. I'll need to take a break and fill my bottle. Have you found it? Alright, so I believe you have found it by now. And you've discovered that network bandwidth is referring to the fact that imagine the blockchain can do a lot of transactions per second. Of course, the blockchain is distributed across, the record is distributed and managed by a cluster of computers from the initial definition of blockchain. So that means this cluster of computers, if for each slot leader in multiple slots that is able to validate and put a new block and all that, each of the computers connected to the network would have to be downloading that record. So imagine, for instance, Cardano with Ouroboros Hydra is able to handle transactions per second of like 1 million. I mean, each computer has to be downloading 1 million records per second. That's going to be crazy. The network bandwidth is going to be crazy. Super crazy. And so there's going to be a network bandwidth problem. And this is one of the current problems even blockchain computers and nodes are facing. Downloading records constantly. So it's very crazy. And when they now finally breach with transaction per second, this problem is going to surface like crazy. So the idea is, how can we handle this network bandwidth problem? Because you take a very large bandwidth to be able to download this record so fast in that same second, so that none of the computers on the blockchain are lagging behind others. Otherwise, some computers on the blockchain will be more updated than the other ones, and before you know, the blockchain is not the blockchain, because all the computers are not on sync. I mean, in sync with one another. So how does Cardano plan to handle this network bandwidth problem, which is trying to get all this record of all the many transactions that are happening in a second as fast as possible on all computers connected to the node? We can't leave this to the computers themselves. So the protocol or the blockchain itself has to do something. And Cardano plans to use what is called RINA. Now, RINA, what's RINA? The full meaning of RINA is recursive internet network architecture. Okay, recursive internet network architecture. And with RINA, Cardano plans to basically split the Cardano blockchain network into sub-networks. Of course, let's say we have computers. Just imagine a cluster of computers. Computers on the blockchain. Just imagine computers everywhere. Like computers. Of course, the blockchain is crazy. Thousands of computers. And of course, we said all these computers are connected together, peer-to-peer-ish kind of connection. Don't mind the way I'm drawing this. So it's not as if this guy is centralized. I don't know. There's no centralization here. I'm just trying to draw everything like. Just imagine these computers are connected. It looks as if this guy is at the center, but it's not at the center. Please, pardon me. So the idea is this: what RINA is basically trying to do. Remember, imagine we are doing this 1 million transactions per second, different slot leaders are the same, because if Hydra, with a reverse Hydra, if you can have multiple epochs at the same time, it means there will be multiple slot leaders at a given time. Each of the slot leaders are adding transactions to the blockchain. It means all the and the idea of the blockchain that every single computer is supposed to be updated. The record on a single computer is supposed to be updated. See, you understand? So that all the computers have the same record and are constantly, they are the same level basically, and they are constantly validating that this record is true. Otherwise, the blockchain will be out of sync. And of course, it will take a very large bandwidth to do that. So what Cardano plans to do is this: is to group each of these computers on the blockchain, this blockchain network, into sub-networks. So this side now can have their own sub-network. This side now have a sub-network. This side now have they are on their own sub-network. So the idea is there are some things, some records of some of these transactions that will be common to a sub-network. So we expect that these computers in this sub-network, their records will be very, very similar with one another, but might not be exactly as much as this, to be able to handle the boundary problem. So all the computers in this sub-network now, we have exactly the same amount of record at a given time. Whereas this one might just lag a little, but we will not, when he needs to do some validation, can easily pick data from other, they can easily talk with other networks and update their own data. So what I'm trying to say is that the whole Cardano network is not going to be grouped into sub-networks. The sub-networks have the data, the record in sub-network are exactly updated. Okay? And this remember, the record in this one now is that this record and this one are exactly similar compared to these ones. Isn't it? Because this is in a sub-network, and because they're handling 1 million transactions per second, when the reverse Hydra comes, they'll be handling 1 million transactions per second. So these guys, because perhaps maybe there's a slot leader somewhere here that has updated some transactions, these guys have a record of that transaction more recently. These guys might take a lag to get it after some time, okay, because they have to communicate with themselves to update. But this cluster here are more connected with one another. Okay, so this is the crazy idea of Rina. And the beautiful thing is, at some point, they might not even need to, at this network here, might not need to have all the record of what is here. But once they need to do the record for some validation, they can easily get it from other networks. So it sounds so crazy, and it's one of the very complex things. A lot of computer scientists are saying, is this possible? That we have some network that might not have the record, but once they need to do some validation, can easily pick it from every other network and quickly update themselves. It looks so crazy, but this is the crazy thing about Rina. Okay? So this is basically what Rina is trying to do. The whole network is grouped into sub-networks. Since computers in the same sub-network have very, very similar records. Other computers in another network also have very, very similar records. But each of the networks know how to share their records when necessary. Okay? So, not to go too in-depth into all of this, but this is, I think, a basic level idea of what Rina is trying to do. Of course, Rina still looks very, very vague, even as of now. But the Cardano team, they are working on it, and what I really believe is, as man, we can do anything we set out to do. Let's look at the next. Of course, the next scalability problem we have is storage. Of course, you remember what storage is. The blockchain, we said, is immutable. Things there cannot be changed, cannot be deleted. All the records are going to be there. So imagine the blockchain becomes adopted as just pick your phone as an example. Imagine your phone is storing files that cannot be deleted. The drive you have on your phone, the storage is write protected. You can't delete anything. I mean, after some months, or even let's say a year, let's say the storage space on your phone is so large, where you're getting files, getting music and the rest. After sometimes the storage gets filled, you can't delete it. How do you handle that problem? That's basically the storage problem. So imagine the blockchain gets massive adoption, big businesses are using it, little people are using it. Files on the blockchain cannot be deleted because the idea of the blockchain is we want to keep track of every single record. Nobody has manipulated any record, nobody has deleted any record, all the records are intact. So how can we handle that storage problem when we get massive adoption and storage space is being consumed heavily? These are crazy things, and these are one of the things that can make the blockchain very expensive, because people will start competing to buy storage space. So, but the idea is they need to solve this if we want to make the blockchain gain massive adoption and come to override what we currently have, which is Web 2. So they have to solve this. So how does Cardano plan to solve it? Currently, Cardano is not really focusing on this because there are a lot of problems. Reverse Hydra, Rina, these are two key ones. Because of course the world still has a lot of storage space, kind of. So Cardano is not really focused on this. But they have plans. They are planning to use things like partitioning. They plan to use things like pruning and compressing. Okay, pruning, partitioning, compressing, and the rest. Of course, from their names, you have a little idea of what these things basically do. Pruning, there are some, usually on the blockchain, when we are storing records, there are some things that are typically very, very relevant, almost so very relevant, but based on the algorithm, they come in check with the algorithm of the blockchain. They come in like that. So one of the things is to prune those things off when the storage problem starts to come. Of course, because the storage problem is not there yet, some things are just left hanging. Just imagine you are writing a line of code and you have so many unnecessary things at some point. Usually at the beginning stage, because you are focused on achieving your goal, you might not worry about them. But then as you develop the software more, you begin to go back and say, let's pick out all these unnecessary things, and just so that the software is smoother and better. So pruning, that's what it does. Then partition is basically to sectionalize some of the records to different parts and all that. Then compressing, of course, from the name, to see how we can compress some of these records without losing them. This is crazy. So this storage problem itself is another food for thought, but a lot of blockchains are working on it, and I really believe it's going to be figured out. Especially compression. The way compression is going now, you can compress a file, you can compress a very large file into a small file and be able to expand it back sometime later when you need it. So compression is really going to help a great deal if we are to have something like the blockchain where no key record is lost. Alright, the other challenge, of course, after scalability, remember the other challenge of the generation 1 and generation 2 blockchain was interoperability. Do you remember what interoperability means? Interoperability. Of course, we are saying different blockchains are solving a lot of different problems. There's a blockchain now called Audios. That Audios, basically, the idea of Audios is basically to help musicians to be able to do things on music, be able to have more rights, more royalty on their music stuff. And Audios is solving this problem, for instance. Now imagine there is a project that starts building something else, but at some point needs some of the features that Audios had used. Because this blockchain are not interoperable, this other set of blockchain will now have to start creating their own kind of functionality to be able to do that thing. Whereas they can just connect to Audios, tap that feature and move on and focus on bigger things. So blockchains need to be interoperable. So Cardano plans to solve this problem, and they're using a lot of ways to work on it. And they say they enable users to add meta. They said Cardano, according to what I have here, Cardano hopes to be the internet of blockchains. Okay, the internet of blockchains. There are different blockchains where they're going to be able to communicate with each other. They are using side chains, using some other things like that. And Cardano hopes to be the internet of blockchain, which causes various blockchain, each with its own protocol and operation, to communicate with each other. Also, Cardano seeks to enable users to add metadata to each other, to each action if they want. This will further soften the hearts of the regulatory bodies and governments. Okay, basically what this is trying to say is another common challenge with the blockchain is that sometimes a lot of governments feel people doing things on the blockchain are anonymous. For instance, the way the Bitcoin blockchain is designed. Even, remember I told you the Bitcoin blockchain is transparent. You can see the last transaction that just happened on the Bitcoin blockchain if you want to. But the idea is you don't know who made this transaction. You can't see the name of the person that has done it, and you can't see the name of the person he has sent it to. All you see is a key, a public address, and some hashed key kind of. So because of this, most of the regulatory bodies are saying fraud can happen. You can't track exactly who has done this and all of that. So what Cardano is also trying to do is to enable the blockchain to be able to add metadata. So for instance, if government say, okay, this particular Cardano blockchain, we want to start using it for businesses, but we need to know who made the transaction. We need to know the name of this person that made the transaction. So a developer that's trying to build the software on Cardano to try to do a monetary transfer that follows the government regulation, whereby government wants to know the name of the person that is doing this transaction. Cardano provides a space where the developer can request for a metadata. So the owner of the blockchain can just have to put his name. The owner of the person authorizing the transaction can just have to put his name and all that, and then it's going to be done across the blockchain. So this is the crazy idea. So it allows you to add metadata and some other things through which you can put in some information if you want to put it in. Okay, even though it's totally optional if you want to put it in. So with this, the government and body can begin to soften and all that. Then for the core interoperability problem, I don't think in this slide I don't think I really have how they plan to achieve it. So I don't really have how, but basically they say they are going to be that internet of blockchain where almost virtually all blockchains can communicate with themselves. This is going to be crazy because I really believe perhaps why I don't have it here is because there's no one way to do it. A lot of blockchains have different protocols, have different things they are doing, different, some of them have even slightly different languages. So saying they will communicate and relate, of course there might not be exactly one way to do that. So that's why a lot of people say the Cardano project is very, very ambitious. But there's something about man, our ambitiousness that's taking us to part of where we are today. That's gaining. I don't want to use the word ambitious because it might look a little too unpleasant to the hear. But that curiosity, that maybe curiosity is not even the right word. That yearning to learn, that yearning to develop, that yearning to enlarge, that yearning to improve, that yearning to be better, that yearning to be perfect as our Heavenly Father is perfect. I think is what is driving us. So the Cardano project, I believe they're gonna get there, even though this whole thing look ambiguous. Sustainability. Do you remember sustainability? That's the next one. Want to challenge Generation One blockchain out. Even Ethereum, like I said earlier, they had this challenge at some point. Sustainability problem is because the blockchain is just developing. Most of and blockchain has not really gained mainstream adoption as such. So most of the blockchain projects, when they want the way they try to get funding, they can't just go out and start doing some public fundings, and some of them can't just or because maybe there are not even so much people to listen to them. What they try to do is to do ICOs. So the idea of the ICOs is the people giving them funds to do the ICOs, they are more or less investing in a coin. They know they are going to benefit. They are not really, some of them might not even be interested in the project. They might not give a care them about what the project is going to be in the end. But there's a way they're going to benefit from the ICO. So the idea of the ICO is just to like give them something to make them invest in the project. Okay, so usually most blockchain projects, because blockchain is still like that hidden tech that people are still skeptical about, people don't want to invest in. So because of it, they always try to raise funds using ICOs, which is a way for people that don't even care about what the project is to come and invest and sometimes make money. And of course, some people who care about the project also invest using ICO. So because of with ICO, they're able to raise some money. I don't want to go into deep on how ICO works, but because they can get some money from people who don't even care about the project, but are just interested in making some little gains, and some people who care about the project anyway. So they try to raise money with ICO, but then after ICO, what happens again? At some point, they start running out of cash because blockchain, of course, is a very new field. Look at Cardano, for example, trying to do Rina or Robust. These things have not even been done. Have not been done. Rina, for instance, I don't think has been done. Perhaps there are some proposals around it, but that's not been done. So they are taking a new path, totally new path. So doing this, there will be a lot of trials and errors. Things might not work exactly as you projected. You might spend a lot of money and need more money. So a lot of blockchain projects suffer because they can't sustain themselves after all. Because the blockchain is still a very wide field. People are actually trying to figure out where to put our legs and a lot of other things. So it's going to be very crazy. And because of that, some blockchain projects just die off. So Cardano is thinking, with all these crazy things, how will we sustain ourselves? So one of the things Cardano is trying to do is to add what they call the treasury. So now, usually when you do something on the blockchain, when you try to do something on the blockchain, a fee is charged to also compensate whoever is validating your block, the computer that is validating your block. Okay, so I don't want to go into all of that. We will see that later, especially when we start creating smart contracts. We will see what we mean by gas fees. Okay, so but a fee is charged. So what Cardano is planning to do is to be able to sustain themselves. On every fee, a percentage is taken into what is called the treasury. So not all the money is going to be used or as fee to the block validator. It's going to be taken into a place called the treasury. And therefore, the treasury, it's very, very restricted and can also be accessed. It's a smart contract kind of thing. Can also be accessed based on votes by all the people, validators on the blockchain, because the treasury, it looks as if it is a fund like owned by the nodes on the blockchain. Okay, so but Cardano is the people working on the project Cardano are the ones that will eventually get the funds to be able to do one or two more projects that they want to do. So what Cardano is basically trying to do here is trying to build a family around their nodes. So the people running on the Cardano nodes are not just trying to validate blocks and get some reward, which they will naturally get, but out of some of the fees, they are contributing to further promote the Cardano project. So the Cardano project is building a family, and if you really try to look at it, one of the strongest thing about Cardano is the bond they have, the family. You need to listen to Charles.
on YouTube, listen to Charles when he speaks, his live streams. It's amazing. There's this different level of thinking. Cardano project bonds with their community. So that bond, the community wants to support, because if Cardano project grows, the developers running the node are going to grow and explode. Just imagine those that started running Bitcoin node. Nakamoto Satoshi, for instance, have about 1 million Bitcoins, which is, I think, the largest amount of Bitcoin. How did they get it? By running Bitcoin nodes in the early days. I have some people I watch on YouTube, my friends, some of them I don't know them physically, but they started running Bitcoin nodes early in the days. They were getting 50 Bitcoins as early as then. You can imagine what it means, 50 Bitcoin then for running nodes, and it was not even too much. Difficult level was not high. So those running Cardano nodes now, even though they are contributing very tiny amounts to the treasury, they will be excited for the Cardano project to grow. Because once it grows and gains a lot of massive adoption, they will benefit. Currently, since I think from December, around November 2020 till now, around now, Cardano has basically over 60x the price of Cardano. Do you know what this is? For something to 60x. That means, look at you putting 100,000 on Cardano at November last year. I'm just talking of investment aspect now. I'm thinking like I'm digressing from the course. Multiply this by 60. You can imagine what has happened. You are currently sitting on 60 million naira, dollar, or whatever. So it's crazy. You put in 1,000 naira or dollar, you are currently sitting on 60,000 naira dollar just from November last year till now. There's hardly a stock that will do that. 60x, not times 2, not double, not triple, 60x. Because Cardano seems to be expanding. So the nodes that are validating this blockchain, they benefit a lot. So indirectly, this treasury is just like, this treasury is basically, some of the fees are supposed to go to some of the nodes that are validating the blockchain. A very small fraction of it is being put in this treasury. Okay? So then whenever Cardano wants to do a project, developers of Cardano, when they want to do a project, because the way Cardano is built is crazy, it's amazing, and it's open. So developers want to build a project, they submit proposals to the people, the community, which definitely will be the people on the node. They submit a proposal, these are the projects we want to do. The community votes which of the project they think is more urgent, because of course it's their money that's in the treasury. Then with smart contracts, the money can be released from the treasury to fund that project. This is how Cardano plans to sustain itself. Alright, it might look so much crazy, but this is just like a summary of sustainability. Then let's quickly look at energy consumption. Of course, do you remember what do you think would be the major problem, energy consumption problem for generation 1 and generation 2 blockchain techs? Of course, it's because they were using proof of work. They were using proof of work technology. Of course, again, over and over again, I've explained what proof of work is. Like I said earlier, proof of work is basically that consensus algorithm whereby computers have to compete. And remember, not all the computers are going to validate the block at last, but all of them are going to use up energy to try to solve the problem. Imagine all the computers on the Bitcoin network. There are so many computers, all of them using electrical energy to try to solve a problem, and then there's only one that is going to get to win and do the actual thing. But with proof of stake, we already know who is going to validate the block. So all the computers don't have to do anything. They just have to wait for only that person validating the block to validate the block. The person is not even trying to solve a very difficult problem. He's just going ahead to validate the block. So he's going to use very little amount of electrical energy. In short, I don't have a record for Cardano, but I have a record for Ethereum 2.0. Ethereum 2.0 says that the power cut from Ethereum 1 to Ethereum 2.0 will be over 99.95%. I'm talking 99.95% power cut of energy. So this is very, very crazy. This is what Ethereum 2.0 used to achieve with proof of stake. So with proof of stake, you already know who is the slot leader. You already know who is going to. So computers are not competing to solve a problem. They're not even solving a complex problem. They're just using whatever power they have to validate a block and put it in the blockchain, which is not so heavy as solving the problem. Because solving the problem is what takes a lot of energy. So because of that, the energy consumption has reduced. And of course, because the energy consumption is so low, the miners validating the block can basically choose to start using renewable energy sources, solar panels and the rest, and stop polluting the environment, which is another thing the government is always against with the blockchain for. So proof of stake has really slowed down. Of course, Cardano is using proof of stake and all of that. So this is how generation 3 blockchain plan to solve some of the problems generation 1 and generation 2. Generation 3 blockchain themselves have a lot of challenges, but I would not want us to look at so much on that today. So that being said, we are done with the generations of blockchain. And I really want to thank you for listening this far. So I will go get some water and we're going to look at the present day applications of the blockchain. Thank you.